Experimental design. Now in this preview of our lesson, we're going to talk about different types of studies and the advantages and disadvantages of those studies. Now, again, important to remember to keep those student notes handy, but first let's go ahead and do this preview before we begin the actual student notes. Let's start with what's known as an observational study. In an observational study, the researcher merely observes what is happening or what has happened in the past and tries to draw conclusions based on these observations. So as an example, if a researcher looks at the number of registered vehicles in the US from the years 1990 to 2015, then the researcher merely looking at a historical data set, and there's no intervention by the researcher in the process of gathering and reporting this data, meaning that this data is reported to him or her, and then a conclusion is potentially made off of simply the observation of this data. Now, there are certainly advantages of the observational study. And one of the advantages of the observational study is that observational studies are typically carried out in a natural setting, meaning that there's little to no interference when it comes to simply observing data. Another advantage of observational study is that observational studies can be carried out in situations where intervention by the researcher would be considered unethical or even dangerous, such as in the case of crime statistics. So when you know an observational study has been done, again, you realize that there has been no tampering, no intervention. It's, again, strictly observation. Another advantage of observational studies, they can be done using variables where manipulation is impossible, such as studies involving height, age, and race. Now, although we have these advantages, there are certainly some disadvantages. One disadvantage of observational studies is that you have a definite cause and effect relationship that cannot be shown since the researcher cannot manipulate other influencing variables. What if there was something about this study that was actually throwing off the data and not creating an accurate picture? Well, then the researcher, based on an observational study, cannot intervene. Because I know the word manipulate can be kind of a negative word, but in other ways it can be a positive thing, depending on the situation. But another disadvantage is that the research is subject to the inaccuracies of other data. So what if the data that they are seeing is actually not very accurate data? For example, crime statistics from the 1800s. Obviously, we have made a lot of leaps and bounds since the 1800s. Or health statistics from another country. What if this country is underdeveloped? Then clearly those statistics will not be very useful. Now, another type of study is known as an experimental study, where the researcher actually manipulates one of the variables and tries to determine how the manipulation influences the other variables. As an example of an experimental study, when a pharmaceutical company tests the side effects for experimental medications, they will administer a placebo to a control group and the actual medical therapy to the treatment group. Once again, there will be a placebo to the control group and actual medical therapy to the treatment group, meaning some people get the medication and some people do not. However, in a typical test like this one, they will not tell who gets the placebo and who gets the actual medical therapy. They would then compare to see if a statistical significance exists between the incidence of a side effect between the two groups. Now, as there are advantages and disadvantages to observational studies, there are also advantages and disadvantages to experimental studies. One of the advantages of an experimental study is that the researcher can decide how to select the subjects and then assign them to groups such as, like I said in the previous example, control versus treatment group. Also, the researcher can manipulate variables such as dosages in medical studies and so on in order to see how it affects other variables in the study. There are disadvantages of experimental studies, but I would choose to get to that later in the lesson, so be prepared to discuss those in a moment. But now is the time to, again, take out your student notes, follow along with me, and as always, make sure you fill out the blanks and let me know if you have any questions. So now that you know the idea of what we're going to be talking about, let's go ahead and repeat with a slightly different approach. Again, there are two types of statistical studies, observational and experimental. Let us begin with observational. Once again, observational studies are when researchers observe what is happening or what has happened in the past and then draw conclusions based on strictly the observations. As an example of an observational study, let's say we have employees are rated as more competitive and less competitive. A researcher simply checks their resting blood pressure and then finds that more competitive employees have higher blood pressure. So this particular researcher was simply checking their blood pressure and was noticing that the folks that have higher blood pressure seem to have a more competitive spirit in the workplace. Now, experimental studies. In an experimental study, the researcher manipulates one of the variables of interest and tries to determine how that manipulation influences the other variables of interest. Now again, that word manipulates sometimes can be pejorative. Sometimes people see that word and they think that's not a good thing. But in this particular case, most of the time when you are trying to manipulate certain variables of some sort of experiment, many times the reason behind it is to test the outcome of other variables. And again, hopefully in a typical experimental study, even though that word manipulation can drive negative connotations, hopefully the manipulation is done in the open so that everyone can see what is the actual effect of changing those variables. So as an example of an experimental study, and bear with me, there's going to be a lot of reading over the next few slides, so I would recommend you underline and circle certain things that you find interesting. But for this example B of an experimental study, let's say we had a group of patients and they were diagnosed with some particular condition, and let's say they are randomly assigned into two groups. Group 1 is given a traditional treatment that has been moderately successful in times past. The second group, though, has been given a new treatment that shows the possibility of being even more successful. So in this particular case, it's not one group gets a placebo, which basically means there's no medication given to them at all, but they don't know that, and then the other group gets the medication. Both of these groups are getting medication, but one seems to be a newer and more successful treatment. Now, the doctors providing the treatment and the patients are not told, that's the key, which treatment they are being given. At the end of the experiment, researchers will compare the two groups to determine if the group receiving the new treatment have better results. This is a true experimental study in which the participants are assigned to groups randomly. Another example of experimental study is, let's say we have a yoga class, and participants were asked to hold a position known as a plank as long as possible during their 2 classes per week for 4 weeks straight. In another similar yoga class, participants were asked to increase the length of time the position was held by 15 seconds each day. During the last class of the experiment, the average length of the time the 32 participants of the first group held the position was 4.5 minutes, while the average length of time the 37 participants of the second group were asked to increase their time by 15 seconds each day was 6.1 minutes. So the first group resulted in 4.5 minutes, The second group resulted in 6.1 minutes. The conclusion was drawn that the group who were challenged to improve performed better. The researcher manipulated, there's that word, the variable of the type of instruction given to the participants. The yoga classes chosen were intact groups, so the researcher did not have the option of randomly assigning the class participants to each group, making this an example of what's known as a quasi-experimental study. Because what if one group was superior over the other in that perhaps one group had a lot more young folks in one of the classes as opposed to the other one? Or what if one class was meant for more elderly or senior citizens? Then that clearly is going to be a different type of group. So this is more known as a quasi-experimental group study. So hopefully the participants of each class have a similar makeup. Now, a couple more terms that you are needing to know are independent and dependent variables. The variable or variables being measured, the resultant variables are called dependent or outcome variables. Again, those are the variables that are being measured. For example, in example B, the independent variable is the treatment given to the groups of patients. And the dependent variable is the response of the patients to the treatment, which are the medical results. And in example C, the independent variable is the instructions given, and dependent variable is length of time that they get to hold the position. Because again, the independent variable was the fact that the instructor was giving two different classes, two different instructions. But the instructor was looking for the same outcome. Now, you pretty much know what treatment and control groups are, but I will repeat them here. And in an experimental study, the group for which the independent variable receives manipulation is called the treatment group. And the group for which the independent variable is not manipulated is called the control group. Now, I mentioned this before, but I left out the disadvantages of experimental studies, so I'm going to go ahead and provide them here after I repeat some of the advantages. Now, again, the advantages of an experimental study is that participants can be assigned randomly, keyword randomly, to the treatment and control groups, and hopefully they represent the population well. Also, the independent variable can be manipulated. And again, this is usually done in the open. This is usually done to show what changes in the independent variable create changes in the dependent variable or the outcome. Now, finally, let's talk about the disadvantages of an experimental study. One, they often occur in laboratories or special classrooms rather than in natural settings. So they're kind of done in situations that are contrived as opposed to just happening in nature. Also, the Hawthorne effect. This is a disadvantage. The Hawthorne effect is a phenomenon that occurs when participants' behavior changes because they are involved in an experimental study. Okay? So it's kind of like what they say, the phrase when people say they're just putting on a dog and pony show. Basically, when the dogs and ponies know they're being watched, their masters become a bit more probably disciplinarian in how they present them to the judges, and therefore probably wouldn't normally act like that in a natural setting. So again, it's because the participants know that they are in some sort of study, they have different behaviors. And not always, but it is possible. Also, there are variables known as confounding or lurking variables. okay, that is not being studied, recorded, or manipulated. And this may actually influence the outcome of the dependent variables. Many times we look at statistics, and you never know where these statistics come from, and you need to be very careful about what statistics you believe. But some people believe certain things because they have certain ideas, philosophies, political backgrounds, whatever it may be. And the point is sometimes that these confounding or lurking variables are dismissed because it supports what they believe or whatever statistic they want to see. So it is important for us to remain impartial and objective when it comes to statistics, knowing that occasionally statistics that have a few lurking or confounding variables may actually not be accurate statistics at all. All right, let's repeat the advantages and disadvantages of observational studies. Advantages: they occur in natural settings. 2. This type of study can be used when it would be unethical or dangerous to manipulate the independent variable. 3. Variables cannot be manipulated, such as ethnicities or left or right-handedness, and they can be studied by simply observing. Some disadvantages of observational studies is that cause and effect cannot be shown, so sometimes the data that you are seeing may not be incredibly accurate, and maybe they didn't take the precautions necessary to truly um, you know, produce accurate data. Studies may be inexpensive or time consuming. Excuse me. So I meant expensive. Sorry. And the point is that again, because you're not able to manipulate things, you are not able to sort of get the results you're looking for. Not that you're trying to look for results, but sometimes we're trying to test to get the most honest answer out of these statistics. But observational can be expensive or time-consuming at times. Results are subject to inaccuracy, and it's due to the dependence on who collected the data. Keep in mind that two different studies regarding the same independent and dependent variables may result in different or conflicting results. So one might be superior over another, so just be wise about which study you decide to approach when you're working on these things. Now, there are some general guidelines for a statistical study. So I would recommend you definitely not only write this down, obviously, in your student notes, but also to make sure that you are kind of putting this to memory, because this is a great way to help you get started on a statistical study. First and foremost, we need to formulate the purpose of the study. Why are you doing this study? Why is that? And knowing why you are doing the study will cause you to be more prepared for what's to come. Next, identify the variables for the study. Very important to identify the independent and dependent variables and decide which, if it's an experimental study, then to decide which variable to manipulate to see how the other one reacts. Next, define the population. Very important. Make sure that you find a population that suits your needs for that particular study. Decide what sampling method you will use to collect the data. Some sampling methods are superior over others. Others are not so great. So please make sure that you decide the proper sampling method. Next, once you decide the sampling method, collect the data. Once the data is collected, you'll, of course, summarize the data, then perform any statistical calculations as needed. And last but not least, interpret the results. Now, let's go ahead and explain how statistics can be used and misused. And I really want to, focus maybe a little bit more on misused, not only in today's class, but also in the future, because if you know the incorrect ways of conducting a statistical study, then you'll be more clear on what is the correct way to conduct a statistical study. But statistical studies are sometimes reported in a way to sell something that actually don't work or prove something that the study did not address. Okay? You ever heard of the phrase straw man argument or a red herring, things like that? Besides, statistical studies actually do not really prove anything. Rather, they provide evidence to support not support a premise, or to engender fear, shock, or outrage. So certainly, if you want to engender fear, shock, or outrage, a stat is actually a pretty good way of doing that. But again, you want to be genuine as to promote your society and to promote good public policy. So some more ways of seeing how they can be misused. Even though the results of a statistical study are reported, does not mean that they are reliable. But people think they are, right? But for example, what if you read something online about some sort of statistic that maybe supports your own philosophical ideals? What if the sample they provided was way too small? What if the subjects may not have been selected randomly? And finally, probably the worst way of doing a study is what if they took the results and misinterpreted them, either purposefully or accidentally. Either way, it's terrible. The whole statistic is destroyed. But also the use of poor sampling methods could also cause how stats can be used and or misused. By simply not picking the right sampling method could be harmful. But also, in the sample itself, what if your sample is not large enough? Usually when it's not large enough, it's because it does not represent the population. Or what if the participants may be volunteers, or perhaps those with strong feelings for or against the premise with a built-in bias? If you find out that if you're trying to run a study and you have someone there that has a very built-in bias, that's going to throw things off significantly. Certain sections of the population, such as those who work or the elderly, may have been systematically excluded because perhaps they can't get to the location where you are conducting the study. And for things such as convenient sampling may have been used, such as in intact classrooms. You might have only asked the folks that are closest to you, so you don't have to travel too far. These are some poor uses, I should say, of sampling methods. Also, another one that you got to watch out for is what's known as an ambiguous average. So let's say you take several values, including the value that occurs most often, the middle value of an ordered list, then the arithmetic average, or the mid-range, could be reported as the average or typical value. Now, the average lends the most evidence in support of the researcher's position, but it's likely to be reported because of potential ambiguity. Okay? So, for example, the Jeff Bezos effect. Now, I don't know if this is actually called that, but I coined the phrase, I guess, is that the Jeff Bezos effect. Now, if you don't know who Jeff Bezos is, he is the owner of Amazon, and I'm almost certain that most, if not all of you, actually utilize Amazon to one degree or another. And as a result, Jeff Bezos is the richest man in the world. So imagine I'm taking a poll of all of everyone's salaries, like what you guys make a year. And let's say I got a salary and I did a little tally of how much money you all made a year. Well, being that you are students, you probably don't make very much. And so if I were to take all of your salaries and I were to add them up and divide by how many students I have within earshot of me, okay, if I divided all your salaries divided by how many students we have in the class, you could probably imagine that a student doesn't make very much money, but the average would make sense. The average would be probably somewhere in the $10 to $20,000 range, maybe a year. Perhaps that's not too much money. However, if Jeff Bezos came into the class, I mean, last I checked, he was worth over $100 billion. And imagine we threw his income into the mix and then averaged his income to your income, and then said the average would be pretty astronomical. And you would think to yourself, I wish I made that much money. So the Jeff Bezos effect is essentially this, that if you actually add up all the data points and then somebody just completely throws it off, he's known as an outlier, and I'll explain more of that later in the semester. Another very important thing to watch out for are known as detached statistics. And a detached statistic is one in which no comparison is made. As an example, let's say that 95% of dentists recommend brand A toothpaste. So let me go ahead and circle that statement. I'll read that again. So let's say you saw a statistic that said that 95% of dentists recommend brand A toothpaste. Now, if they recommend it, then that's fine. But this is a little bit misleading because is this brand recommended instead of another brand? So instead of what other brand? Or do the dentists recommend several brands, including brand A? So maybe these 95% of dentists recommend this brand, but are they recommending it on top of other brands? And they're conveniently leaving that fact out? Or are they saying that brand A is superior to another brand? Another example, you might see a sentence like this. Cookie B has fewer calories. Well, what does that even mean? It has fewer calories than what? Right? Than what it used to have. Maybe they changed the recipe a little bit. Then another brand. Very misleading. And there's things like this where you have to be very careful when it comes to statistics. You cannot just look at a statistic and run with it all the time. Sometimes you have to ask those questions. Last but not least, there are other types of misuses. So another misuse is what's known as an implied connection. Use of words such as may help. Doesn't really help us, but can skew the interpretation of data. Misleading graphs. That's a big one. A lot of misleading graphs are used, especially when it comes to election time. Faulty survey questions. How questions are phrased in a way that influences the way people answer them. So you might ask a question that forces people to answer it in a specific way. Whereas you're supposed to ask more like questions that are supposed to give people freedom to answer it in the way they truly believe or think. Now, there are other ways of actually misusing statistical data in order to achieve certain results. And I'll go over those more and more as we progress, but these are just a few.